So, you guys, what we've done up until this point is Module 1 was doing mole-to-mole stoichiometry. Module 2, we're doing moles to grams, or we're doing grams to moles, one of the others, okay? Now what we're looking at, this is the third module, okay? The third module involves doing what we call mass-to-mass stoichiometry, and that's going to be the longest type of stoichiometric problem that we're going to do in this class, okay, is the mass-to-mass. But it is by far the most common type of stoichiometry problem that you're going to see, is the mass-to-mass stoichiometry, okay? So has everybody got this problem up here? Module 3, y'all have that in front of you? Okay, mass-to-mass examples. All right, so it says, when copper metal is added to a solution of silver nitrate, silver metal and copper 2 nitrate are produced. What have I been telling you guys is the very first thing we need when we start any stoichiometry problem? Balanced chemical equation. You got it. So the very first thing I've got to do here is I've got to write out a balanced chemical equation. All right, so we're going to do copper and,
That's what you're doing.
yep, you got it. Copper and silver nitrate. Silver nitrate has the chemical formula AgNO3. Okay. And it says what gets produced is silver metal, so that's Ag. And copper 2 nitrate, which has the chemical formula CuNO3 2. Okay? So there's all of my reactants and my products. Is that equation a balanced chemical equation? No. How many nitrates do we have on the left? We've got one nitrate ion, polyatomic ion on the left. How many nitrates do we have on the right? 2. So how can I get 2 nitrates over here on the left? Put a 2 in front of the AgNO3. You got it. Okay? Perfect. So what Connor noticed just then is when I put a 2 in front of the AgNO3, I now need to balance the silver. So I now have not only 2 nitrates, but I've got 2 silvers. So we're going to go over to the right-hand side here, and we're going to add a coefficient of 2 in front of the silver. Now is my equation a balanced chemical equation? Yes. So we've got our balanced chemical equation. Next, it says, what mass of silver metal? Which thing in this equation is the silver metal? The Ag. So over here, we're going to write how many grams of silver metal. It says should be produced from the reaction of 100 grams of copper. So over here on the left, 100 grams of copper. And it says when it reacts with an excess of silver nitrate. All that means is we've got an unlimited supply of the silver nitrate, the AgNO3. We've got as much as we need, but we've only got 100 grams of the copper. And once I use up that 100 grams, all my copper is gone, and the reaction is going to stop. Okay? So this is an example of what we call mass-to-mass stoichiometry, because the unit that I'm given is grams, and the unit that I'm solving for is grams. So this is mass-to-mass stoichiometry, okay? But I cannot convert grams of one substance directly into grams of another substance, okay? What did I tell you? If you want to go from one substance in the chemical equation to the other substance in the chemical equation, what unit do we have to go through? We have to go through the mole. You got it. So I'm going to have to take this 100 grams of copper. And you guys, that was 100 with a decimal. That does affect your significant figures. So we're starting with 100 grams of copper. But I know immediately that I've got to convert grams of copper into what unit? Moles. I have to convert grams of copper into moles of copper. Okay? So to convert between grams and moles, I need to use what? Periodic table. I've got to use the periodic table to get the molar mass of copper. So when I go to the periodic table, I found out that 1 mole of copper had a mass of, what do you guys see on there? What number? 63.55 grams. of copper. Okay? So it's the molar mass. But this time, instead of going from moles to grams, I'm going from grams to moles. When I go from grams to moles, I divide by the molar mass. Do you guys see that? When I want to convert grams to moles, I divide by the molar mass. Okay? So now what we see is that grams of copper cancels out. I'm now into units of moles of copper. So now what I can do is I can go from copper all the way over here to silver. I can go to the other substance using my mole-to-mole ratio. So I can convert moles of one substance into moles of another substance using the mole-to-mole ratio. So from my balanced chemical equation, how many moles of copper do I see in the balanced chemical equation? 1. Where do I want that 1 mole of copper to go? On the top or the bottom of that fraction? On the bottom. So my 1 mole of copper is going to go on the bottom. And then my coefficient in front of the silver is 2. So I'm going to put 2 moles of silver on the top. And so now moles of copper cancels out. But am I currently in the unit that my problem asked me to solve for? It did not ask me to solve for moles of silver. It asked me to solve for grams of silver. But we can convert moles of silver into grams using what? The periodic table. We can use the periodic table and the molar mass of that substance to convert moles into grams. So I've got to look up the molar mass of silver. 107.87 grams of silver for every 1 mole of silver. Remember, it does not matter if there's a coefficient in front of that substance. That coefficient does not get factored into the molar mass. The only time the coefficients ever get used, you guys, the only place the coefficients ever get used is right here in our mole-to-mole ratio. Okay? So, what am I going to type into my calculator based on what you see here in our train tracks?
100 times 2 times 107.87 divided by 63.55.
Good. We're going to type in 100 times 2 times 107.87 and then divided by 63.55. Okay? How many significant figures did we start with in the number 100? 3 significant figures. So how many significant figures do we want in our answer? 3 significant figures. Okay? So let's type that into our calculators. 100 times 2 times 107.87 divided by 63.55. And then round it to 3 significant figures. Tell me what you guys get. Good job. 339. And as Jackson included there, units, that is grams of silver. So 339 grams of silver is how much silver would get produced from the reaction of 100 grams of copper with excess silver nitrate. Does that make sense? Okay? So, you guys,